Hi, I'm Phil, and today we're going to look at the M5Stack Puzzle unit and a couple of projects that I've done with it. Let's have a look at it and what it is. So we can see the construction of it. It's actually an array of 8 by 8 RGB LEDs. R stands for red, G for green, and B for blue. So you can get some colourful patterns as long as they fit inside the 8 by 8 array, and you can have any combination of colours you want. It's using a fairly standard and well-known LED, the WS2812, and I've used that on many occasions over the last few years. So you can see that it has Grove connections of Grove in and Grove out, and it provides another connector in the package. So that's what it is. And here's another view with the connectors on. And here we've got the 8 by 8 array on the front as you see it. It was only recently released a couple of weeks ago, and I've received it about 4 or 5 days ago. So not a lot, $7.50, and you can apply it in lighting designs, displays, and in interactive installations. So I guess some of my projects would go into that category. And the features of it, it's an 8 by 8 array, and it has Lego holes, which is very convenient because you can mount it on Lego boards. Hardware-wise, well, let's have a look at the package. This is what you get when you purchase it. There's the specifications of it. The schematic, they provide everything, the schematic, you can actually see how it works. No smart electronics involved here, just a string of LEDs that go along a row by row basis and until you get to 64. The pin map, depending on the core unit from M5Stack you use, the GPIO pins will change. Although it is the same for the core and the core 2, it's only different for the core S3. And there is a warning not to set the brightness too high. So I'm only going to use 10%, and that is the advice that they give for projects that are going to be on for a long time. Software-wise, there's the Arduino IDE, has libraries for it. But in addition to that, and I haven't listed it here, we might do that now. We can add that we've got UIFlow support now for it too. So there's our software. And the projects, I've done commissioning tests with patterns, drawing patterns on the screen. And let's have a look at a couple of those, see if we can find. The objective there was to test and commission, have a look at the new functions, and combine 3 puzzle units together. And those 3 puzzle units go into the second project where I've got traffic lights. And for today's video, this is where I'm focusing on. So when I put everything together, I'm using a Core 2 computer connected to 3 puzzles, and we're simulating traffic lights on both the Core 2 screen and also on the array of puzzles. So let's have a look at the objective behind that. Design, and I want to design and construct a single set of traffic lights using puzzles, and I'm going to duplicate much of the software with the 3 puzzles. But I'm also going to put circles on the Core 2 unit. I'll be using buttons for that. and I'll follow the recommendations for brightness. Design-wise, I'm going to subdivide it into modules, and I'm also going to allow some manual testing by using buttons A, B, and C on the Core 2 unit. Hardware-wise, I'm using a Core 2 with a Core 2 bottom. It has its own battery, but more importantly, it allows me to add two more ports B and C. So we now have 3 ports, and I'll be using those for my traffic lights. So there's the puzzle unit. I'll be using 3 of those and 3 Grove cables. Connection-wise, everything goes together like this. So we might actually go across now and see the construction. So let's put the hardware together for our traffic lights. First thing, we take a Core 2 computer, and on the bottom, we add the Core 2 bottom. Now, while it has a battery, what we really want it for are the 2 extra ports. That's ports B and C, so that we can add 3 traffic signals. So what we do, we connect for downloading the program, a USB, although we will be downloading over Wi-Fi. And this is our final arrangement, where we've got 3 M5 Puzzle units, 1 on port A, 1 on port B, and 1 on port C. And that's the hardware configuration for our traffic signals. So let's have a look at the software. I'm using UIFlow, and this only became available a couple of days ago. So I want to test out to see if it works. So I'm using the user interface, and I'm painting this on the screen. So I'm using circles for my traffic signals: stop, check, and go. And I've got the 3 buttons A, B, and C here. The units, I'm using 3 of these on the connected to ports A, B, and C. And code-wise, this is my code. I might go across now, and we'll have a look at that code in detail. So here we have the software for our traffic lights using the UIFlow IDE, and that comes from the M5Stack website. So there are 3 components here. On the far left, we've got our screen, which we paint, and we're using buttons. So the buttons are here, and I just drag them across, and I just fill in the parameters. So if you look at the parameters here, we might just get rid of that one. You look at the parameters, I've got the width and the height both on 70, and normally the lights will be off until they're activated by software. The buttons are actually here, just below the label. So there's A, B, and C, and they'll be used for manually controlling or manually looking and making sure that our lights are working. The middle area is where our toolbox is. And as we add more units, the units are down here, and I've got 3 puzzles. Each of them are connected to a different port. So if you look at this one, that's on port A, there's on port B, and port C. So they're using all the ports that I have available on my Core 2 with its battery bottom. And if we look at the units, we've only got the puzzle, and I might actually zoom up on that so you can see the available. So the one I'm going to use will be this one. which will be the puzzle, and setting the palette on the puzzle. But you could actually set patterns and even letters or numbers with different colors on the screen, on the puzzle face, if you want to. Okay, we'll go to the right of the screen, and this is where our software is. So on the top right, we set up, and under that we have a loop. And for our manual testing, we use buttons A, B, and C. And then when we start moving off to the right, we process, each column is processing one of the traffic phases. So the red phase is this column. The next column is the yellow. And on the far right, the column there is processing green. So let's have a look at this in detail. So we'll go back to setup. And you can see I'm setting up the puzzles 0, 1, 2, and 3 to match the colors of the traffic signals. This is only testing. It's not really necessary. It's just initializing, and it doesn't last long. So, and I'm also setting the brightness of the puzzles, and those commands just follow. And I'm also testing the buttons and setting those up to colors too. Then I set up my parameters, and the interesting thing about this program is that you can set the timing for each of the phases with the time green max and red and yellow max. And after I wait 5 seconds, I then go into the loop, then just go through each of the phases: red phase, green phase, and yellow phase. And here we've just got setting green for our testing procedure. Now, in the red phase, I won't go through all the phases. They're all quite similar. But what I'm doing here is just increasing the label size when I press one of the buttons. So to set red, the label there is just set to a higher label for 2. Then we then turn on the puzzle. So we're setting red here, and that means that puzzle 2 goes red while the other 2 are black. And for the function set red 2, we do a similar thing with our touch button. And the red phase calls each of the 2 above and just goes through a timing loop and terminates at the end of the red maximum. The other 2 are similar. And that's the software using UIFlow for traffic lights on Puzzle. So putting everything together, the hardware and the software, everything worked quite well. And looking at the results, I was able to achieve all the objectives, that is, construct the traffic lights, and I explored combining 3 puzzle units in my design. Extensions-wise, I'm going to go further with new projects, particularly with music, and I'm going to relate music to color using the Boom Whacker color protocol. And we'll do that next week in a separate video where I'll look at the Boom Whacker's color and how our puzzles will emulate the Boom Whacker colors. So if you're interested in this, go across to the M5Stack, the shop and the wiki. So where it looks like, let's have a look at. We'll go to the shop first. And here's the device on the website, on the shop. So you can see what it looks like, the description and the product features. So it's actually sold out quite quickly. I bought 4 of those, and I've noticed they've changed their marketing arrangements where they announce a new product, but only allow a small number to be made available. hoping people realize that there's a shortage and they'll buy a few more. We'll go back and have a look at the website. So there's their wiki, and here's the support on the wiki. Not many examples. In fact, there's none at all. So you have to create your own. And that's the puzzle unit by M5Stack. Here we have a M5Stack Core 2 computer, and it's hosting 3 puzzle units on the left, and we're simulating traffic signals.